You know, in the world of proxy networks, trust is absolutely everything. But here's the thing. When every single provider is telling you their network is 100% ethically sourced and packed with real users, how are you supposed to know who's for real? Well, in this explainer, we're going to dive into the one technical method that just cuts right through all that marketing fluff and shows you what's really going on. So, yeah, that's the big question, right? Is your proxy provider actually telling you the truth? We see these buzzwords plastered everywhere. Opt-in networks, genuine mobile IPs, real residential devices. Sounds great. But behind those comforting words, the reality can be, well, completely different. We could be talking about data center servers or, even worse, hacked devices. So how can we prove what's really going on? Okay, let's get into it. The tool we're going to use for this little investigation is called TCP fingerprint analysis. Now, the best way to think of it is like a digital magnifying glass. It lets us look right past the slick websites and all the promises and see the raw, undeniable evidence of what a proxy network is actually made of. So what in the world is a TCP fingerprint? Well, it's basically the unique network signature that every single operating system leaves behind. Just like a real-world fingerprint, no two are exactly alike. The way Windows PC talks on a network is a little different from how an Android phone does it, and that's different from an iPhone or a Linux server. And these tiny little differences, well, they tell a massive story. And this slide right here, this just perfectly shows the gap between the marketing spin and the hard reality. On one side, you've got the claim a beautiful, diverse network of real phones and home computers. But on the other side, the TCP fingerprint, it just doesn't care about marketing. It reveals the truth. What looks like a mobile network could actually be nothing more than a big, uniform rack of Linux servers. All right, so how do we actually run this investigation? We're going to approach this just like detectives, okay? We're gathering clues directly from the network traffic itself. We are not taking anyone's word for it. No way. We're going to be collecting hard, forensic evidence right at the packet level. The whole process really breaks down into 4 key steps. First, pretty simple, we collect a bunch of IP samples from the provider. Then, and this is the important part, we analyze something called the SYN packet. Think of it like the initial hello in any digital conversation. After that, we look for clues that a machine is virtualized. And finally, we check out its NAT behavior, which tells us if a bunch of devices are sharing one connection, like they would in a normal house. So all the really juicy evidence is found inside that initial hello, that SYN packet. We're looking at all these little details, things like window size, but honestly, the most important thing is the specific order of the TCP options. A real Android phone, for example, arranges these options in a very unique order, an order that's totally different from a Linux server. These are the subtle, really hard to fake details that give the whole game away. And this brings us to my favorite part, the revelation. After we've gathered all our clues, we start to see these patterns emerge. These are the red flags that tell us, hey, something isn't quite right here. These are the smoking guns that expose when a network story just doesn't match up with reality. And here it is. This is the #1 biggest red flag of them all. Just imagine this. You test thousands of IPs from a so-called residential network, and every single one comes back with the identical fingerprint of, say, an Ubuntu Linux server. It is physically impossible for thousands of different homes with different routers and devices to behave identically at this level. This is the biggest giveaway that you're just looking at a server farm, not a real user network. But there are other signs for sure. If a provider is selling you mobile proxies, but you can't find a single Android or iOS signature in the bunch, that's a huge red flag. Another one is when the timestamps are just too perfect. Think about it like a sterile, clean lab versus a chaotic, busy street. The lab is predictable, right? The street is messy. That's the difference between a server's timestamps and a real user's device, which is always messy from background apps. And if the OS doesn't even match the IP's carrier, well, the clues really start to paint a very clear picture. This table just sums it all up perfectly. On one side, you have a genuine opt-in network. It's diverse, it's a little messy, a little chaotic. You get a real mix of operating systems and natural variable timestamps. But on the other side, a suspicious network is just unnaturally uniform. It's clean, it's predictable, everything looks the same, one Linux fingerprint, perfectly regular timestamps, and no signs of a real home environment. Okay, so we've done all this technical analysis. We've gone deep. But why does this really matter? This isn't just some interesting academic exercise. The verdict from our investigation has some serious real-world consequences for any business that's relying on these proxy services. It really comes down to these three crucial reasons. First up is performance. A genuine network with real user IPs just behaves more naturally, and it's way less likely to get detected and blocked. Second, risk. I mean, if a provider is using sketchy, non-consensual methods, your business could be facing serious legal and reputational damage. And finally, just honesty. You absolutely deserve to get what you're paying for. The marketing claims have to match the technical reality. At the end of the day, you just can't hide from the physics of the network. A provider can write whatever they want on their website. They can promise you the moon. But as this analysis shows, the packet-level truth, it will always leak out. The evidence is right there for anyone who knows how to look for it. So that really just leaves us with one final, very important question. For any business out there that's relying on proxies for scraping, for market research, for ad verification, this kind of analysis isn't just interesting. It is essential. So is your business doing its due diligence? Because now you know exactly how to find the answer.